On a clear night, man raises his eyes to the sky. He has the immense privilege of being the spectator of one of the most beautiful works that nature has to offer. Raised in the sky, a multitude of celestial luminaries, which are the stars, offer a delight for the eyes. This fascination for the magnificence of the heavens has one day given birth to a science, astronomy. The discoveries that followed have allowed a considerable advance in the knowledge related to our cosmos. Today we have significant technological means to try to pierce the secrets of what we see but cannot reach. Telescopes, satellites, robotic vehicles sent to survey planets inaccessible to man. Astronomy is evolving at great speed, and we know more and more about the universe. These discoveries confer to the modern man a feeling of omnipotence on the world which surrounds him. But on the contrary, the awareness of the immensity of the universe has more than ever made man smaller. Whereas a few centuries ago, the human species thought it was the center of the world and placed the Earth at the center of the universe, modern cosmology has scientifically proven the error of this perception. At that time, mankind was assigned a place of prominence, but today, thinking tends to consider the human species as a speck of sand that appeared by chance in a vast cosmic ocean. Does the human species have a privileged place in the universe? How did the Earth, life, and then man appear? What future can we predict for Homo sapiens? In order to better situate the place of man, it can be useful to look at the events from another angle, from the beginning of the universe until today, in order to understand where we come from and where we're going. Dear traveler, good morning. Today, we're leaving for an exceptional journey through time and space to discover the immensity of the cosmos. Before leaving for a new adventure, think of liking the video and subscribing to the channel to not miss anything. Thanks to all, and have a nice trip. In cosmological terms, the universe is defined as everything that exists. This is a brief definition for a subject that has fascinated and aroused curiosity for thousands of years. Since the dawn of time, man has been aware of his insignificance in the universe, and his view has evolved with the discoveries and technological advances. Indeed, thanks to the glasses and telescopes, it passes from a universe observed to a measured universe and becomes aware of the reality of the extent of the universe which surrounds it. We are in 100,000 BC. The caveman is on his guard when he leaves his cave, for fear of being confronted with climatic phenomena. He attributes these phenomena to the anger of the sky that he does not control. For him, the wind, the rain, or the lightning are caused by higher spirits, to which he must submit by making offerings and sacrifices. A little later, imprisoned in religious considerations, men will attribute to the universe super-powerful gods who govern the world. These supermen would use the elements of nature to punish and subdue them. In Egyptian astronomy, for example, the universe is imagined by gods. The earth was Geb. Above him stood Nut, the goddess of the sky, supported by Shu, the god of air. Ra, the sun god, was moved by two solar boats, by day through the sky and by night through the realm of the dead. With time, in parallel to these beliefs and guided by the progress of research in astronomy, men looked at the world differently and accept the intelligible reasons of the first discoveries. In Babylon, 5,000 years ago, men estimated the position of celestial bodies and highlighted the constellations. At the same time, the Egyptians elaborated sundials in order to determine the length of a year and to locate themselves in time for a better management of their harvests. In 1500 BC, the Chinese astronomers, and before them the Mayans, located Venus, Mercury, Mars, and Jupiter. The closer planets, they even presented for the first time an atlas of comets in the form of a silk ribbon 1.5 meters long. Although this new data approaches the universe from another angle, it is only in the 6th century BC that the Greek civilization will impose a more structured and justified scientific thought, free from myths and beliefs. Although still unverifiable by observation, ideas were nevertheless rigorously constructed, doctrine after doctrine, from master to pupil. This is how a new conception of the Earth as round and no longer flat as a disk emerged over the centuries. A scientific universe was outlined under the influence of Thales, Pythagoras, Plato, Aristotle, Archimedes, and many others. In the 3rd century, Greek scientific thought seemed to run out of steam, as if it had stopped at Ptolemy's Almagest, a collection of all the astronomical knowledge of the time which describes a geocentric universe in which the Earth, spherical and immobile, is enthroned at the center of the heavens. In the 8th century, the Arabs took over and gave birth to generations of astronomers who were unjustly ignored and who made progress in techniques and science. During the medieval period, the Church took over and influenced the thinking of the state. The Almagest and other works arrived from Spain and were translated into Latin, but only made available to monks. Henceforth, only one God rules. The bowels of the earth become hell, purgatory is found between the earth and the moon, and purified souls will have the chance to join God beyond the sphere of the stars. The day and the night translate an unceasing fight between the good and the evil. This period will not have allowed a great advance in the field of astronomy. In the 16th century, technical advances and the evolution of the human mind freed astronomy from theology and religion. It is Nicholas Copernicus who will make astronomy take a considerable turn by dislodging the Earth from the center of the universe to position the sun there. His hypotheses were so innovative for the time that he preferred to postpone the publication of his work on the revolution of the celestial orbs, which was finally published in 1543. In 1613, Galileo also defended the idea of a heliocentric universe, but was condemned for his statements that went against the teachings of the Bible. From then on, the hypotheses had to be subjected to experiments and mathematical demonstrations. From the beginning of the 17th century, observation and measurement were the preferred practices, and astronomy was then considered as a branch of mathematics rather than physics. It was Isaac Newton who marked this century with his famous theory of gravitation, which he generalized to the entire universe. He also developed a new model of telescope based on a mirror lens. Throughout the 19th century, considerable progress was made in the fields of electricity, magnetism, and optics, so that in the following century, innovative theories appeared, taking into account relativity and the quantum hypothesis, which attempted to model the behavior of energy on a very small scale. Scientists thus set out to describe the world of atoms, abandoning the vision of a deterministic universe and favoring the idea that all cause and effect relationships are continuous. In 1920, Edwin Hubble demonstrated that the universe is in motion and that galaxies are moving away from each other. Associated with various other theories, including that of relativity, scientists begin to speak of a phenomenon of expansion of the universe, which leads to some answers on the birth of the universe. Indeed, if the universe increases with time, it is that it must have been smaller in the past, and that there must have been, therefore, a time when the cosmos occupied a single point as a cosmic seed. What if we went back in time, 13.8 billion years earlier, where it all began? Until the beginning of the 20th century, scientists agreed on a fixed universe since the dawn of time. However, in the 1920s, astronomers, including Edwin Hubble, demonstrated that the galaxies were moving away from each other, and thus proposed the theory of an expanding universe. To better understand this phenomenon of expansion of the universe, let us compare it to a balloon growing. The fundamental question of the appearance of this same balloon before being inflated then follows naturally. The Big Bang is the theory relating to the birth of matter, and consequently of the universe. The result of the work of mathematicians, physicists, and astronomers over centuries, this major event, which is unanimously accepted by scientists, would have taken place approximately 13.8 billion years ago. An initial flash of creation, which occurred for reasons that are still somewhat unexplained, caused matter to appear, leading to the formation of everything that surrounds us, from subatomic particles to galaxies. The Big Bang owes its name to an astrophysicist, Fred Hoyle, a fierce opponent of the theory of expansion of the universe. In 1950, he used the term Big Bang in an interview in a totally ironic way, without even knowing that the cosmological model would keep this name. The birth of the universe took place very quickly, in just 3 minutes. 3 fundamental minutes that will lead billions of years later to the existence of man. But at this precise moment, man is not. It is the matter which dominates. The elementary particles of matter are now there, and they will draw in the future all the chemical elements which compose the wealth of our world. Let's take a look back at these 3 incredible minutes that followed the Big Bang. Once upon a time, there was an explosion filling all space and time. The universe begins its history a fraction of a second after this explosion. At that moment, it is hotter and denser. Its dimension is incredibly tiny, on the order of 10 million billion times smaller than an atom. Light cannot travel far. The horizon of the cosmos is close, but the energy is immense. This energy even injected by the explosion. The universe then sees an exponential increase of its expansion, called today inflation. It goes from the size of smaller than an atom to a grapefruit. It becomes less dense, but also less hot. The first elementary particles appear: quarks, electrons, and neutrinos mixed with photons. And because the universe is electrically neutral, antimatter also emerges. Particles and antiparticles embrace each other, giving birth to light. In a short time, the universe will go from 10,000 billion degrees to 100 billion degrees. The movement of quarks slows down, allowing them to regroup by 3 to form neutrons and protons. A new nuclear force will intervene to gather protons and neutrons with a remarkable precision and will constitute hydrogen and helium. 3 minutes after the Big Bang, 98% of the mass of the universe is built, with 75% of hydrogen nuclei and 23% of helium. It will thus continue its expansion, quietly, over the next 380,000 years. The temperature of the universe reaches then 3,000 degrees Celsius, or 5,432 degrees Fahrenheit. We're still far from the appearance of the universe in which we currently evolve, but at this time, the electromagnetic force makes a remarkable entry by playing a significant role in the construction of matter. By pushing protons and electrons, it will cause the formation of the first complete atoms, hydrogen and helium. This is a big step in the history of the universe. Indeed, the photons having finally the freedom to propagate freely, the light gushes for the very first time. The universe then becomes visible, and it will remain so. The fusion of hydrogen and helium will give birth to all the missing chemical elements. The first stars and protogalaxies were formed between 200 and 600 million years after the Big Bang, and the solar system was born 9.3 billion years after the Big Bang. Matter then began a continuous transformation that continues today. Let's see now what the current universe is made of, after 13.8 billion years of existence. The universe is the whole of the matter and the energy distributed in space-time. It is composed of billions of galaxies, themselves made up of billions of stars, around which planets can gravitate, forming a system. It's estimated today that the diameter of the observable universe is 100 billion light-years. All the structures composing it are in perpetual evolution. The galaxy in which man evolves is the Milky Way. With at least 200 billion stars and more than 100 billion planets, scientists estimate its diameter to be up to 200,000 light-years. The Milky Way is the home of the solar system, and consequently of the Earth, the home and origin of mankind. Observed from the Earth, the Milky Way appears as a whitish band forming an arc in the sky. Among the stars that make up our galaxy, there's one majestic star that sparkles and provides light and heat to our entire system, the Sun. About 150 million kilometers away, the Sun is the closest star to the Earth. The solar system is defined by the star, the Sun, and by all the celestial objects that orbit around it. Among them, 8 confirmed planets dance around the Sun on the rhythm of the ecliptic plane. Mercury, Venus, Earth, and Mars, which are telluric planets mainly made of rocks, and Jupiter, Saturn, Uranus, and Neptune, which are gaseous planets made mainly of gas. With a diameter of 1.4 million kilometers, the Sun alone represents 99% of the mass of the solar system. Scientists estimate that it's at the halfway point of its life, and that it could still burn for 5 billion years. The energy released by this sphere of light is of paramount importance for life on our planet, and our ancestors realized this very early. Indeed, many civilizations have studied its annual movement in order to define seasons and to make it an ally in their agriculture. After traveling through the universe in the Milky Way, let's slowly get closer to the planet that brings together the conditions of life for humans, the Earth. The Earth is the third planet of the solar system that orbits the Sun at about 150 million kilometers. Unique in its composition, its climate, and the life it shelters, it provides the ideal conditions for the presence of liquid water on its surface. The planet Earth is in perpetual transformation. Volcanoes that eject molten rock form new land features. Ice ages, rain, and wind are powerful factors of erosion and sedimentation. Nevertheless, the main cause of change remains the movement of the Earth's crust. Huge plates are continuously moving on the surface of the Earth. When these plates separate, new material fills the gaps, and when they collide, mountain ranges are formed. The atmosphere on Earth sustains life and protects against the dangers of interplanetary space. The Earth is composed of 3 layers: the crust, the mantle, and the core. The crust is the upper part of the Earth. Its thickness varies according to its location, and it's mostly made of volcanic rock. Beneath this crust is the mantle, which is much thicker, reaching up to 2,900 kilometers, or 1,800 miles in thickness. It consists mainly of an assembly of oxygen, silicon, magnesium, and iron, called olivine. Finally, at the center of the Earth is the core. This core, made of an alloy of iron and nickel, is divided into 2 concentric envelopes, a liquid envelope for the outer core and a solid one for the inner core. The appearance and the constitution of the Earth are not the same depending on where it's observed from. Let's imagine the Earth, separated into 2 parts by a meridian line, the Greenwich meridian. This results in the Western Hemisphere and the Eastern Hemisphere. The Western Hemisphere covers the entire American continent, the Atlantic Ocean, and a large part of the Pacific Ocean. This hemisphere is therefore mainly summarized by its high water content. On the other side of the Greenwich meridian, the Eastern Hemisphere is mainly dominated by land. The continents Europe, Africa, Asia, and Australia are largely represented. Tectonic activity is therefore very present. But how did the Earth take shape in the universe? The Earth was born 4.6 billion years ago, but before the planets were formed, there was the Sun. The debris of dead stars which would have consumed all their energy would have been expelled into the galaxy and would have formed a molecular cloud composed of gas and dust. The particles of this immense cloud, several hundred light years in diameter, will agglomerate under the effect of gravitational forces. The compression will increase the speed of rotation of the cloud and heat its center until this fireball becomes the Sun. At the same time, the heavier elements such as iron, silicon, aluminum, and nickel will come together to form new planets. As soon as these clusters reach a size of at least 800 meters in diameter, they're able to suck in the surrounding matter. Over the course of about 3 million years, these clusters will gather in the solar system to form up to 20 protoplanets, including the Earth. The protoplanets will then collide and combine, so well that after 30 million years, we can count our 9 current planets. The Earth is then far from resembling the one that shelters us today. Indeed, the temperature was more than 5,000 degrees Celsius, or more than 9,032 degrees Fahrenheit, since it was made of molten matter. Little by little, the planet will cool down. The lightest elements will rise to the surface, and the heaviest will penetrate to the heart of the Earth to form the core. But the story of the formation of the Earth does not end there. When it's about 50 million years old, it will experience a shock of unprecedented violence. Another protoplanet the size of Mars will collide with it at a speed of more than 11 kilometers per second. The shock is such that the Earth's soil will remain molten for several million years. This impact also solidified the axis of rotation of the Earth and is at the origin of the seasons. At the same time, the agglomeration of rock residues vaporized during this collision will give birth to the Moon. It is, at this time, much closer to the Earth and appears huge in the sky. And the water in all this? During this period, the solar system is still very hot, close to 1,000 degrees Celsius, or 1,832 degrees Fahrenheit. The Earth does not contain water in a liquid state. No form of life is then possible. Currently, 2 theories are retained by scientists regarding the arrival of water on Earth. 50% of the water on Earth would have originated from the degassing of the mantle. As for the other half, it would come from a meteorite shower from outside the asteroid belt. Indeed, comets are composed of 50% water. Located next to Jupiter, they would have been influenced by its imposing mass to be deflected and collided towards the interior of the solar system until they met the Earth. During these collisions, the meteorites would have disintegrated and would have released water, which, mixed with mantle water, would have formed the oceans. Geologists have estimated that the oceans took 150 million years to fill. The temperature at the surface of the Earth was around 90 degrees Celsius. The atmosphere is then made of nitrogen, carbon dioxide, and methane. Oxygen will still have to wait more than 1 billion years to show up. The stromatolites, which are calcareous structures present in aquatic environments, will transform carbon dioxide into oxygen, but it will not spread in the atmosphere. In reaction to iron, oxygen will precipitate in the form of rust and fall to the bottom of the ocean to become rock. It is only when all the iron has reacted that oxygen begins to accumulate in the atmosphere. Over the next 2 billion years, the oxygen level will increase until it reaches a level that was essential for the appearance of life 500 million years ago. The Earth is the only planet in the solar system that harbors life and allows the human species to develop. But before this could happen, a number of favorable factors had to be brought together at the right time. The first essential condition for life is the presence of water, but under the condition that it is largely in a liquid state. This will, therefore, depend entirely on the distance of the planet from its star. in our case, the sun. If the planet is too close, it could be too hot and the water would evaporate in the atmosphere. On the other hand, if the planet is too far from the sun, the water would remain in the state of ice, as in Antarctica, the largest desert in the world. In addition to the distance from the star, the composition of the atmosphere of the planet also plays a major role. To illustrate these facts, let's take the example of the Earth and the Moon. Both objects are equally distant from the Sun, 149.6 million kilometers, or 93 million miles, and yet the average temperature on Earth is 15 degrees Celsius, or 56 degrees Fahrenheit, while it is negative 20 degrees Celsius, or negative 4 degrees Fahrenheit on the Moon. This is due to the presence of a cloudy envelope, the atmosphere, around the Earth. The greenhouse gases that make up this atmosphere will keep the heat on the Earth instead of letting it escape into space. This is called the greenhouse effect. Thus, the heat is not conserved on the Moon. Then, the position of our planet is in the habitable zone of our solar system. It is the only one with Mars that is. While Mercury and Venus are much too close and have a much too hot temperature, all the others are, on the contrary, too far from the Sun, and therefore too cold. The appearance of life often echoes the first humans who lived on Earth, but in a broader sense, it refers to much older discoveries, because at the origin of life, there is, in the end, only a simple cell. Even if the origins of life on Earth are still uncertain, thanks to research and the discovery of fossils, elements of answers are appearing, and theories tend to explain what could have happened. Until the middle of the 19th century, the origin of life was attributed by most to a single man, a creator, God. Thought was oriented by religious beliefs, since nothing was yet fully observable and demonstrable by science. At the time, people thought that all living things were created as they were by divine intervention. It was Charles Darwin, an English naturalist and paleontologist in 1871, who contradicted this idea. It was in writing to one of his friends that he delivered the essential message that life derives from a chemical process and not from a creation. Darwin proposed a theory of evolution in which he suggested that living species are constantly evolving and undergo morphological and genetic changes over time. Thus, through a mechanism of natural selection, the species that best adapt to their environment reproduce more. According to him, a species becomes another species. What forms did the beginnings of life have several billion years ago? At the beginning of its formation, the conditions on Earth are not very welcoming. Seismic and volcanic activities dominate, and the high heat that prevails make it automatically sterile. Then, the Earth will slowly cool down, and the water it contains will partly condense in the atmosphere. A cloudy layer takes shape around its sphere, protecting it from the sun's ultraviolet rays. It would be in the depths of the oceans that the first traces of life would have appeared, about 3.8 billion years ago. A first trace of life in all simplicity, consisting of a single cell, without organelle or nucleus, a prokaryotic organism that we all know, bacteria. They are the basic elements of life. It is then 3 billion years ago that blue-green algae began to develop. They were the first to produce oxygen by photosynthesis. The first eukaryotes, the first complex forms of life made up of cells with a structured nucleus, were discovered in geological strata dating from 2.1 billion years ago. Different forms of life will then develop, multiply, disappear, be reborn, and reform abundantly. Biological diversity explodes, but remains only concentrated under the surface of the ocean for the moment. From 630 to 550 million years ago, a multitude of species developed, called the Ediacaran fauna. Adapted to an environment poor in oxygen, These species have large surfaces, allowing gas exchanges. In spite of their soft body without skeletons, the great resistance of their fabrics allowed their fossilization. They're related to a kind of jellyfish or soft coral. Appearing 530 million years ago, the Timoshan fauna marks an important step in the development of biological diversity. Indeed, some organisms are then endowed with solid parts. We witness the mineralization of the skeletons. This fauna will survive only a few million years. The last phase of the evolution of life is marked by the Burgess fauna. This fauna marks the biodiversity by its colossal richness and number, and by the complexity of the organisms which constitute it. This fauna appeared 528 million years ago, and suddenly disappeared 20 million years later. It is a fauna of worldwide distribution because it's been found all over the world: Greenland, Europe, China, Australia. The Burgess fauna is characterized by an astonishing variety of organisms never seen before, and very different from each other. Vertebrates will start to invade the seafloor, as well as different kinds of fish. Then, finally, life will come to set foot on the Earth. 440 million years ago, plants, such as mosses, settled peacefully on the water's edge. Then, a few million years later, these same plants will free themselves from the water by developing roots. It's only 375 million years ago that the skeleton of some fish will evolve and solidify, allowing the birth of the beginning of legs. Thus equipped, some tetrapods finally had the ability to move in a muddy environment and to see dry land. But a few million years later, a mass extinction will make many species that evolved until then disappear. The third and most important mass extinction would have occurred 250 million years ago, and would have caused the loss of 90% of the species that lived on Earth at the time. Some of them will then disappear permanently. 20 million years later, the legendary dinosaurs appeared and dominated the Earth for over 160 million years. It is from the mammalian reptiles that the branch of mammals will gradually be born. A small animal similar to the rat, and probably insectivorous, would be the first common ancestor to all mammals. Around 200 million years ago, a penultimate mass extinction took place, leading to the disappearance of the fauna of the oceans. Only a few small mammalian reptiles will survive. Before this event, all the continents were united in a single mass called Pangaea, but after this mass extinction, probably caused by a huge explosion, the continents will start to move away from each other, isolating species that will now evolve differently. A fifth mass extinction occurred 65 million years ago, resulting in the disappearance of 70% of the species, including the vast majority of the dinosaurs that predominated at that time. Without the powerful dinosaurs, mammals will evolve, proliferate, and become more and more impressive within 10 million years. The first traces of primates were found 60 million years ago in southern Morocco. And man in all this? Let's imagine a timescale from the Big Bang to today. Let us imagine that we have on this scale the different stages of the evolution of life on Earth. The arrival of our human species, Homo sapiens, represents only a tiny part of the bottom of the scale. But let's take a closer look at how modern man appeared and what his place is in this vast cosmos. Despite the notable scientific advances in archaeology, the discovery of human remains remains rare, often incomplete and fragmented. Indeed, while soft parts such as cartilage and flesh are impossible to preserve, the long-term conservation of bony parts requires particular conditions that are often difficult to find. Teeth are the best preserved part. However, it turns out that over the years, precious finds have been made during excavations, which gives us a vision on the appearance of humans on Earth. Man is a primate. He's a distant cousin of the ape. The first representatives of the human lineage since it split from that of the chimpanzee are the hominids. Their appearance would have taken place 7 million years ago. It is only in 2001, during excavations carried out in Chad, that the almost complete skull of a new species never before discovered was identified, the first being of the first species, Sahelanthropus chadendus, will be named Tumé. According to research and estimates, it was a human being measuring 1 meter or 3.3 feet and weighing 35 kilograms or 77 pounds. Nearly 350,000 generations separate him from the human beings of the year 2000. 4.2 million years ago, the first humans appeared in Africa, Asia, and Europe. Australopithecines form a genus of prehistoric man who are the closest relatives of the genus Homo. The remains are rare, but volcanic sediments and caves reveal some traces of the activity of man, thanks in small part to fossilized bones, such as teeth, jaws, fragments of bone skull, but especially by the discovery of flint objects that they used at the time, which were then only fragments of stone formed naturally, and not intentionally. Scientists believe that they were isolated individuals. Nomadic hunters themselves preyed at other carnivores. The structure of their larynx suggests that they did not have an articulated language. They knew how to use fire since traces of ashes have been associated with Homo erectus, but they did not yet domesticate it. Their life expectancy does not exceed 30 years. 2.5 million years ago, Homo habilis made its first appearance. This time, bifaces, stones cut on two opposite sides made by human hands, were found. 1.15 to 1.3 meters high and weighing at most 40 kilograms, Homo habilis walks on his 2 feet, is perfectly skilled with his hands, and is a good tree climber. Homo erectus appeared 1.9 million years ago in Africa and remained until 300,000 years ago. It will then colonize a large part of Eurasia and Indonesia. It is the first hominid to migrate outside the African continent. Measuring 1.6 meters in height, or almost 5.3 feet, its bony head is peculiar, an imposing jaw, no chin, thick bones, and a rather low forehead, but its cranial capacity is more developed. The domestication of fire and the making of the first real tools are attributed to them. Then, the first Neanderthals appeared. They are the closest species to modern man. Neanderthal man was omnivorous. He lived from hunting and gathering, but he did not cultivate or raise livestock. He made tools out of carved stones and was able to defeat mammoths, rhinoceroses, and large reindeer. Another particularity of this species is that they buried their dead. They also left traces of their art, pieces of teeth and shells used to decorate jewelry, as well as paintings and engravings on walls and caves. They disappeared 35,000 years ago. It was only around 200,000 years ago that Homo sapiens, more commonly known as modern man, appeared. He is in no way the descendant of the Neanderthal man. They are two very different species. They have, however, at one time cohabited, and must have been brought closer since we have recently discovered that we have some genetic material of Neanderthal origin. Several species of Homo have existed on Earth, but Homo sapiens is the only one still alive today. The Neanderthal man, pushed back from the best hunting grounds by Homo sapiens, will consequently end up weakening and will disappear in less than 30,000 years. Homo sapiens remain then the only ones on Earth. The oldest Homo sapiens discovered so far were located in Ethiopia, and it seems that the species originated in Africa. It would then have taken advantage of an improvement of the climate to migrate to Europe around 30,000 years ago. Then it would have finally moved more widely and would have occupied all continents. Contrary to popular belief, Homo sapiens were tall, measuring between 1.7 and 2 meters, or almost 6.6 feet. They lived in a cold era and sewed skins to cover their body. They evolved their tools by adapting them to their needs. They lived in the entrance of the caves to take advantage of the light and heat. They domesticated fire and lived from hunting, fishing, and gathering. It is 10,000 years ago that men will pass to an economy based on agriculture. Indeed, following a warming of the climate, the ice melts, the level of the oceans rise, and large forests appear. The fauna also evolves. Since the mammoths become extinct, the reindeer migrate north, and the horses and bison become non-existent. Man will evolve from predator to farmer. This is the beginning of sedentarization. The cosmic calendar of Carl Sagan is a rather singular approach dealing with the place of men in the immensity of the universe. Carl Sagan is an American scientist and astronomer. His television series Cosmos aimed at popularizing scientific information and was broadcast on television in several countries. It is in this perspective of popularization that Carl Sagan invented a calendar of 1 year in order to bring back on a human scale the history of the universe from the Big Bang to today. Thus, the first second of January 1st corresponds to the birth of the universe, and December 31st at midnight is equivalent to the present time. In this new timescale, each second represents 400 years, or 37.5 million years per day, and therefore 13.8 billion years for the year. We are on January 1st. The Big Bang takes place at midnight, and the universe is born. During the night of January 2nd to 3rd, the first stars are formed. The first galaxies will appear on January 1st, but ours will be waiting longer until May 12th. Many generations of stars follow one another, enriching the environment with heavy atoms, until September 1st, the day that marked the birth of the sun. We're now on September 9th. Planets are clustered around the newly arrived star. On September 14th at 6 a.m., the Earth is formed. The next day, the Moon is formed and begins its rotation around the Earth. All the decor of our solar system is in place, and we're already in autumn. It is then that, thanks to the stability and the heat, physico-chemical processes start. And around September 25th, life appears on Earth in the form of single-cell organisms, bacteria. For 2 months, these bacteria proliferate and invade the planet. The first multicellular beings will arrive at the beginning of November. December is the busiest month in the history of the universe. On December 1st, we witnessed the formation of a terrestrial atmosphere endowed with oxygen. On December 15th, we witnessed the Cambrian explosion, which defined the sudden appearance of most of the major current phyla of multicellular animals. Then follows, chronologically, between December 17th and 23rd, the birth of the first invertebrates, oceanic plankton, fish, the first vertebrates, the first plants on land, the first amphibians and insects, and finally, the first trees and reptiles. It is now December 25th, and it is the turn of the dinosaurs to make their entrance. They will remain present until December 30th, when the arrival of an asteroid will be fatal. In the meantime, the first mammals were born on December 26th, birds diversified on December 27th, flowers and fruits on December 28th, and primates on December 29th. On the 30th, parallel to the disappearance of the dinosaur, the Great Reign of Mammals begins. It is only on the last day of the year, December 31st, that man will take his place in the universe. At 2 p.m., a primate climbs down from its tree. In the evening around 8 p.m., the human lineage splits from that of the chimpanzees. Australopithecus appears at 21 hours, and Homo erectus at 23 hours. It will be necessary to wait until 23 hours and 48 minutes to find traces of Homo sapiens, and 23 hours and 50 minutes for him to domesticate fire. In the last minute of the year, he will invent agriculture, writing, and find metals. It is thus in the last 10 seconds of the year that history with a capital H will be condensed. This report of the history of the universe on 1 year highlights the insignificance of our existence in the cosmos. In this cosmic calendar, man does not have a privileged place, since he has glory only during the last few seconds of the year. The universe is immense in the visible part, immeasurable if we consider all that man does not see. Its measurements are made in billions of kilometers, or in light years, numbers which exceed the understanding of man. In order to better visualize the part that man represents in the immensity of the cosmos, we're going to bring back our small corner of the universe, the solar system. Measuring 20 billion kilometers, that is to say almost 12 billion miles, on the scale of a city of about 20 kilometers. The dimensions are thus divided by a billion. The sun would be approximately the size of a balloon, the moon would correspond to a pea, and the earth to a grape. Man, for his part, cannot even be represented because he's so tiny. The balloon, the grape, and the peas are, let us remember, arranged in a space of 20 kilometers, an imperceptible part of tiny in a disproportionate space. It is in this sense that in the 1900s was born a philosophical current led by an American writer, Howard Phillips Lovecraft, the Cosmicism. A self-proclaimed irreligious man, Lovecraft postulated that there is no divine presence in the universe, and that in this galactic infinity, humans are particularly insignificant. For him, Homo sapiens would only be a primitive species that arrogantly thinks that they have a crucial role to play, even though they have no power to change the universe around them. This Darwinian line of thought, inspired by the theory of evolution, suggests that man is only a pawn in a cosmos in which other species live. In his stories of strange fiction, human beings are often prey to powerful beings or cosmic forces that are never ultimately malevolent, but rather indifferent to humanity. The insignificance of the human race remained the main theme of Lovecraft's works. The universe is constantly changing. It is officially admitted today that the universe is growing, stretching. How can man find his place in this cosmos filled with variation? What future does the universe hold for us? Should man place his hopes in space exploration? The expansion of the universe designates the phenomenon by which objects composing the universe, galaxies and clusters, move away from each other. This separation is interpreted by a dilation of the universe, and not by a movement of the galaxies themselves. Let's imagine for a moment a large cake, still raw, on which would be arranged chocolate chips, close enough to each other. This cake is now put in the oven to cook. As the cake bakes, it swells, and the chips move away from each other. This image is comparable to the phenomenon of expansion of the universe, by imagining that the chocolate chips are the galaxies. It was in the 1920s that the idea was first discussed that the universe was not in fact static and unchanging, but was instead expanding, dragging the Milky Way and all the other galaxies along with it. This is a fact that is now well established, but since this discovery, cosmologists have been trying to determine with precision the rate of expansion of the universe. Recently, through a review published in 2019, astrophysicists claimed that the speed of expansion had increased by 9% compared to those younger years. The universe is therefore expanding faster. This new discovery leads us to rethink the understanding of the universe, but also its future. The scientists agreed rather on a version in which the expansion of the universe was slowed down by the gravitational force of celestial objects. Current research has made it possible to explain this phenomenon of acceleration by the presence of a large-scale repulsive force that would be able to fight against the force of attraction of celestial bodies. This force, still very mysterious to the world of cosmology, is called dark energy. The future of the universe is one of the most important questions in cosmology. Several rather different scenarios are now considered to try to project into the future. First, it is necessary to define whether the universe is closed or open. The finite or closed universe implies that the matter contained in the universe will be sufficient to slow down and then, at a given moment, stop the expansion of the universe. Thus, the force of attraction of the matter will make the distances reduce little by little until reaching a phase of contraction. This reverse phenomenon of the Big Bang is called the Big Crunch. This scenario of universal collapse is however considered obsolete since the 1990s, when the increase in the speed of expansion of the universe was discovered. The infinite or open universe implies that its expansion continues indefinitely. In this scenario, all galactic objects will have an end. The sun as well as the other stars will be extinguished. Over time, the suspended matter will diminish, and fewer stars will be created. All these extinct stars will clump together into black holes, and the container, space itself, will be nothing but a bath of photons without structure. It is then that all energy in the universe will be extinguished. And what about the future of humanity in all this? Stephen William Hawking was a British theoretical physicist and cosmologist. He's recognized worldwide for his theories, books, and public appearances. His popular science books have made him known to the general public. His best-known works are on black holes, cosmology, and quantum gravity. In his last book, Brief Answers to the Big Questions, published in 2018, the year of his death, Stephen Hawking attempts to answer 10 questions clearly and authentically. Among them, the question of the survival of the human species on Earth is addressed, and the answer of the theorist is rather pessimistic. Indeed, for Stephen Hawking, humanity's days are numbered. He does not estimate its survival longer than 1,000 years on Earth. He advises us to explore space for the future of humanity. One of the reasons addressed is that of the constant evolution of technological progress. According to him, the forms of artificial intelligence, although very useful, could harm the survival of humanity. Humans, limited by their biological evolution, could find themselves overwhelmed by this new form of intelligence. Genetic engineering could be used to improve certain human capacities and create forms of superhumans. In this context, there would be an elite against which unimproved humans could not survive. For Stephen Hawking, it's better to turn to what unites us, to rethink the notions of wealth and possessions, and to learn to share again. Another reason that worries the scientist is global warming. He considers it as one of the greatest dangers that man should face, and even affirms that the Earth could be brought to resemble Venus, that is to say, to record a temperature of 250 degrees Celsius, or 482 degrees Fahrenheit, and to be prey to sulfuric acid rain. In response to this alarmist future, Stephen Hawking strongly advocates going to colonize space. To do this, he's invested in a program called Breakthrough Starshot, which aims to launch space probes into space capable of reaching the speed of 15,000 kilometers per second, or 9,320 miles per second. Thus, if humans could travel at the same speed, it would be possible to reach exoplanets potentially welcoming to humans in only 20 days. That's a challenge of great magnitude for a civilization that has not traveled to the moon since 1972. Man has always tried to understand what surrounds him in the cosmos, but as soon as the technological progress offered him the possibility of exploration, he knew how to set up the material conditions favorable to his voyage in the universe. The history of space exploration is closely linked to the Second World War. The Germans, having made significant progress in the field of rockets, they're the first to send a missile which will reach an altitude of 100 kilometers, or 62 miles, the limit between the atmosphere and space, in 1944. Then followed the space race, a frantic competition between the USSR and the United States, resulting in a fierce technological competition in which each tries to show its excellence in the field. Space exploration becomes an essential issue of the Cold War. This will result in 3 major events in the space field. The USSR has a step of delay in the field of the space exploration in the years 1950. Thus, it decided to deploy a project with a missile able to transport a bomb, whose significance was its incredible density. It's thus a doubly ambitious project, because the missile must carry a long distance with a load of several tons. Sergei Korolev, a Ukrainian engineer, then set up a very small, innovative satellite. In spite of some obstacles during the tests, it's on October 4th, 1957, that the Sputnik 1 satellite was sent in space. What started out as a simple, small-scale rocket project became a considerable technological advancement. A new limit of the human environment was exceeded on that day. The year 1961 will be marked by the first manned spaceflight in the history of space exploration. A first man is sent beyond our Earth's atmosphere. The race to space is for the moment dominated by the Soviets, and the Vostok 1 mission will confirm at the time the superiority of the space program directed by Sergei Korolev. On April 12th, a Soviet vessel Vostok 3Ka is launched, with on board Yuri Gagarin, a talented fighter pilot native of Russia who became then cosmonaut. It will make a flight in orbit around the Earth for an hour and 48 minutes at an average altitude of 250 kilometers or 155 miles. With this mission, the USSR cemented its prestige in the space field. A month and a half after this event, the President of the United States, John Fitzgerald Kennedy, announces that an American will put a foot on the moon before the end of the decade. It is at this time that the Apollo project is born. This statement pitted the USSR and the United States against each other to make a man walk on the moon. It's at the end of 1968 that the Americans take a consequent advance on the Soviets. They position then a crew in lunar orbit, Apollo 8. Then, during the 6 following months, they chain the missions in order to test scenarios of lunar landing. Finally, on July 16, 1969, the Apollo 11 spacecraft was launched with 3 astronauts on board: Neil Armstrong, Michael Collins, and Edwin Aldrin. The Eagle capsule lands on the moon on July 20th. The next day, July 21, 1969, Neil Armstrong will be the first man to walk on the moon, followed by Edwin Aldrin. The sentence, "one small step for man and one large step for mankind," pronounced by Armstrong, will mark forever the conquest of the moon, in which the Americans take henceforth the advantage on the Soviets. The first step on the moon put an end to the space adversity between the United States and the USSR. The attenuation of the Cold War does not justify then any more of these missions with the exorbitant costs. The context of detente is even illustrated by the Apollo-Soyuz cooperation, which results in an orbital rendezvous of the 2 vessels. The space technologies are then developed with the aim of exploring planets, but also for the commercial use of space, thanks to telecommunication satellites, for example. The objective of the conquest of space takes then quite another sense. The manned flights become a lesser stake, and space stations are built in which a permanently present crew dictates itself to scientific experiments. The great project of the future currently occupying all nations is the conquest of Mars. The objective is to be able to study the soil and find possible traces of life. The planet Mars is intriguing because it's the one that would offer the maximum opportunity to man. It could be the only place apart from Earth where man could settle permanently. Mars is indeed at the limit of the habitable zone. Its atmosphere is equivalent to that of Earth at an altitude of 35 kilometers, or almost 22 miles, and the presence of water on this planet is far from zero. Thus, in the event of a global terrestrial catastrophe, Mars could become our new Earth. The planet Mars is now the focus of international interest and has become the new horizon for the conquest of space. In spite of colossal advances in the field of space exploration, it represents barely the size of an atom compared to the immensity of the universe. The observable universe, defined by the vision we have of the universe through the best telescopes, is 13.8 billion light-years. The entire universe is even larger. The ships take 3 days to go to the moon and 26 months to go to Mars. With a life expectancy of less than 100 years, it's quite illusory for man to travel in space over distances of more than a dozen light-years. In this immense environment, the human species represents only a tiny fragment, and we've never left the tiny spot where we were born. In spite of this, we're progressing, and our hold on the world is widening. Our descendants may go further. We have just seen that the destiny of the universe is not in the hands of man. In the long term, we'll know that the whole solar system will change or disappear, and man cannot currently change anything except to colonize another planet. But for the moment, in the very short term, the greatest dangers for the human species are, inexorably, the consequences of global warming. While man concentrates his time, energy, and money on exploring the cosmos and trying to dominate an environment in which he's powerless and insignificant, he's slowly killing the planet that saw his birth, causing what scientists call the sixth mass extinction. Now, everything seems to indicate this time that climate change is caused by man. Species are disappearing at an alarming rate. Perhaps 40% of them will be eliminated by 2050. The human species is causing havoc with its abundant and indiscriminate development, and the Earth is suffering. Global warming due to human activity is taking its toll. Global surface temperatures are rising, storms are more violent, water shortages are causing many droughts, melting ice caps are raising sea levels, extreme weather events are disrupting crops, and some land and sea species are clearly threatened with extinction as conditions become unfavorable for their development. Without realizing it, man is in the process of causing his own demise, since he could, himself, belong to the species that will be brought to extinction. A serious situation, but not desperate if we keep it our objective to protect the planet and keep it habitable. Even if a part of the population is rather pessimistic about the climate challenge and resigned itself to seeing the environment crisis paralyze the Earth, would it not be the moment for man to prove his intellectual superiority by leading the fight against the sixth mass extinction?